After knowing so many things about partial differentiation, successive, total, and things like that, I believe you are very good at partial differentiation, and therefore let's do on something that is exact differential equation. Alright, so what is totally a exact differential equation? So I'll just start off with a function. Alright, I have this function z. Alright, and if I were to differentiate, if I were to ask you to differentiate in terms of if I were to ask you to differentiate this function, I will believe that you will do partial z partial x, right, plus partial z partial y. Alright, if you don't know what I'm writing right now, this looks something alien, please click this video and go and check it out for partial differentiation. Or if you want to learn more about other stuffs later on, because if you know partial differentiation already, I think you can just continue. But if you want to learn other stuff, then you click this one in my playlist where you have other stuff to check it out. So let's continue. And therefore, partial z partial x, allow me to write it now. I believe you are already professional now, so I'll just fast chop finish. So I differentiate in terms of x, I will have 2y plus 2xy plus 1. Alright, then I differentiate in terms of y, which is what I'm going to do for this case. I would have this one, 2x plus x squared, and then in terms of y, this one will become 0. Alright, and therefore now I bracket this thing first. Alright, now if I were to bring this partial x to this on top, and then this partial y, and I bring it on top, but instead of partial x and partial y, I write it in terms of I write it in terms of dx and dy. Right, instead of partial x now I write dx, instead of partial y now I write dy. Alright, and therefore if I were to sub this thing back into this equation, and then I sub this thing back into this thing, do you find something somewhat similar? This is the type of question, or also equals to 0. Alright, if that's when you see this type of question, you know that this is exact equation and they want you to solve for something else, and what they want you to solve is to solve for this equation that we have just started at just now. Alright, so we are actually working reverse way to solve for the initial equation, instead of previously in the previous videos we are doing in terms of differentiating only. Now we're gonna do something that is reverse. Alright, and before I start talking about exact, alright, I'll just brief you with what are the type of variations of questions that may come out. So this, as you know, is the primary set of exact differential equation. Alright, and we may also have something like that. Alright, do you think that this one is the same as this equation? Yes, right. Then how? Then you just multiply the whole thing by dy lah. Multiply the whole thing by dy. You multiply the whole thing by dy, this one dy cancel, this one become dy. 0 times dy is still 0. Then you are getting back this one. That is the case. So this is one of the variation. Alright, this is one of the variation. The next variation is when if happen that means just copy this. Instead of equals to 0, let's bring this over here. Then they put it like that, minus. You see where I'm coming from right now? So there is a different type of variations question that they may actually give you and then throw at you and then ask you to do, but they are in fact the same thing as this thing. They are just simply rearranging and then trying to make you confused, but this is the thing. So be very careful. Alright? And therefore, without further ado, let's start off with the exact differential equation. Alright? An exact differential equation starts with this one, and then they ask you to solve using exact. And the first type of question they ask you is to prove that this is exact. So how do you prove? The first step you're gonna do is to set this thing as m, mother m, and this whole thing, this whole parenthesis stuff, n for this. Alright? So when I do that, now I need to prove that. Alright, the next thing I'm gonna do is to differentiate. If I see dx, I gotta differentiate in terms of dy. If I see dy, I gotta differentiate in terms of dx. Alright? So I repeat again, if I see there is dx over here, I gotta differentiate this term in terms of dy. If I see this term, this is dy, I gotta differentiate this term in terms of dx. And it's very similar to successive differentiation. If you remember, if you differentiate a certain function in terms of x, and then later on you differentiate in terms of y, then you have partial x and partial y. So this is something similar to that, but totally not related. Alright, but similar, but still, let's continue. So therefore, if I were to differentiate this m in terms of y, y, then what I will have, if I just write it down so that you know what the hell am I doing. So m dx dy, alright, is exactly this term. I differentiate in terms of y. I would have 2 plus 2x, and then this term is gone. Alright, because one differentiate in terms of y is just 0. Now I differentiate this term. Okay, so if I differentiate these terms, is n dy over dx, which is equals to 2 plus 2x. Yes, so 0 differentiate is just 0. So therefore we prove that this is equals to this. Ta-da! That's the answer. But now they want you to solve. The next type of question they will ask, definitely the subsequent one, is to ask you to solve for this one. They want you to reverse to solve for this answer. So how do you solve? Using this one and reverse to find this one. Alright, so let's continue. Right, and I'll just paste, just copy this whole chunk over here, and I'll just paste it over here. Right. Okay, so this is step 2. Step 2 is what we're gonna do now is to integrate. Alright, so let's just write it down as integrate. If you don't know what is integration, or you find that you have forgotten integration, go and click this link to go and check it out. It's a Khan Academy. Alright, so I shall see you soon if you don't know what is integration, and you can come back here later on. Alright, if you know integration well, then let's continue. So I'll just integrate in terms of m, in terms of x. So integrate m dx is equals to, in terms of x, so 2y, I'll just fill it up with x and that's all, plus 2x, because you differentiate x, you're gonna plus 1 over here, so this is x to the power of 1 right? So I have x squared divided by 2. Alright, this is just the formula integration if you remember. Okay, I'm not gonna go through how it works, but there. And then y. Alright, so this term is simply integrated by here. So for example, I ask you to integrate x. Alright, x dx. It should be equals to half x squared. Because if you differentiate 2 down, you'll have x back. Alright, I think you get what I mean. If you don't know, then happy birthday to you, happy birthday to you, happy birthday to you, happy birthday. Okay, so after plus 1 you have x, right? If you differentiate 1 you have x, right? And plus some function of fy, because during your integration you may lost some information of y, right? During differentiation. Normally you differentiate in terms of x, you may lost some, like for example, if you differentiate in terms of like y, right? You lost information of x, right? Because x is not, that's why this becomes 0. This is what I'm trying to mean. So I just leave this form as it is. C1. Now I gotta integrate n in terms of dy. Okay, so I gotta use a slightly different color. N dy is equals to so dy I'll have 2xy plus x square y. I'm just filling it up with y only, that's all. And then 0 is just 0, and plus some function of f(x), because sometimes, like for example, you can see already when we differentiate in terms of y, x is gone, so therefore we just include some function of x in case you may have something, plus c2. Now the next thing is to find all the common terms, right? If you were to look properly, this numerator 2 and the denominator 1 will cancel each other, so in fact this term is equals to this term is equals to this terms, so they are the common terms. Definitely they are inside the equation already, the initial equation already, definitely 2把. Okay, then now you have, for this case you have some function of x, right? And this some function of x is actually this x over here, so just put it in over here, x, and then you don't have any function of y, right? Because there's nothing over here, right? You see, you didn't see anything, right? So you just leave it as nothing, right? Because there's nothing, there's no loss of information during your differentiation of x. But there is loss of information during my differentiation of y, correct? This is what I'm doing, if you remember, if I differentiate this equation in terms of y, x is gone. So this is why I find back my x and just place it over here. And then I just plus some constant c, because c1 and c2 is just some constant, so it's okay, I just write it as c. Right? And this is the answer. So if I were to copy this, and I want to go and paste back my initial where we start off with, ta-da, you see 2xy x squared y plus x plus c, because sometimes there might be some numbers, and this is the answer. So the key thing that I want you to know is that when you're dealing with exact, right, try to make m and n first, and then if you were to prove exact, you differentiate. When differentiating, differentiate in terms of the opposite. If it's x, you differentiate y. If it's y, you differentiate x. And then integration part, when you want to solve back the initial stuff, you gonna integrate in terms of dx, because this is the form. Normally you will see dx, you know that you're gonna place some integration behind it, in front of it. That's a trend, and generally this is the case for exact, but normally there may be more weird stuff going on. So this is the pretty easier one. So I hope that it helps, and I shall see you in some time. Goodbye.